In this video, we will discuss the China exit strategy in Asia model, which is a new model that has been added to the resource library. With China currently, there are economic problems such as COVID issues and port congestion. And historically speaking, there has been an overexposure to China for production. The questions that this model will answer are, should we and how do we exit from China and reduce our reliance on it while still maintaining production within Asia? Looking at our supply chain map, we can see that our market demand is in Japan and that product manufacturing is occurring here as well. In the baseline scenario, which is our current unoptimized supply chain, you can see we are receiving our raw materials from Dairen and Guangzhou, which are both located in China.
Regarding the data, we can see that a majority of our customers are based in Japan.
In the facilities table, we have our distribution centers, which are moving around our finished goods. And we have two plants based in Kansai and Kantao, which are converting the raw materials into the finished products. Next, looking at our suppliers table, we can see the two previously mentioned Chinese baseline suppliers of Dairen and Guangzhou, and three potential candidates of Ho Chi Minh in Vietnam, Bangkok in Thailand, and Kanagawa in Japan, which we will use to build scenarios off of. In the products table, we have our finished goods 1 and 2 and raw materials 1 and 2. If we look at the supplier capabilities table, we can look at where these raw materials are coming from. Specifically, Dairen is supplying both raw materials 1 and 2, along with Guangzhou, which is also providing raw materials 1 and 2. The last table I will call out is the customer demand table. This table will call out the demand quantity of finished products that are expected to be fulfilled by each customer. Without the demand quantity, there is no model to optimize, so this table is very important. Hopping on over to the scenarios tab, this is the area where you create the scenarios to answer your questions. The baseline scenario will be our unoptimized supply chain as it is currently. This will be where our raw materials come from, both Dairen and Guangzhou, which we have seen previously on the map. Our second scenario will show us an optimized view of our baseline scenario. Basically, we are removing the baseline constraints and showing a more optimized, cost-efficient supply chain based on how your supply chain network is currently set up. In the third scenario, we are eliminating Chinese raw materials entirely, and the amount of flow for both Dairen and Guangzhou are now 0. This scenario also excludes the baseline constraints and includes the candidate suppliers in Thailand and Vietnam that have been established in the suppliers table, excluding Japan suppliers, which we can see in the fifth condition. Before we go into the remaining two scenarios, let's go and take a look at the map flow for scenarios 2 and 3. As we showed previously, here are the flows for the baseline. Clicking on the scenario dropdown will reveal the maps filter set for our other scenarios. As we investigate maps for scenarios 1 and 2, the maps haven't really changed much. The amount of sourcing will be the same, however, the baseline flows allocations have changed a bit. If we change the map filter over to scenario 3 with no China sourcing, we can visually see sourcing coming from both Thailand and Vietnam. Now that we have seen our changes, how will this impact our costs? If we start digging into the analytics table, we can start to visualize this. Here we can see the baseline costs with flow constraints. If we simply remove these flow constraints, we are still sourcing through China, and we can see the cost reduction. Sourcing and production costs are the same. However, we can see a drop in the cost of transportation, and this is because we are allowing the engine to optimize the allocation of customers to the distribution centers in Japan. Next, let's look at the cost of no China sourcing. As you can see here, the cost has actually gone up a bit due to transportation and sourcing. In this scenario, we are hoping the risk of exiting China would offset the costs. However, if we look at the overall risk analysis, we can see that our score has increased to 5.4. If we dig a bit deeper into the risk analysis, we can see that the overall risk went up in Vietnam and Thailand due to increased risk with the potential suppliers. As we can infer from these charts, this scenario puts the company more at risk than simply staying in China. Let's go and run a few more scenarios. This time we are going to continue zero sourcing from China, but now we are going to limit the amount of sourcing that can come from Thailand and Vietnam respectively. Looking at the map for our fourth scenario, we are limiting the volume of sourcing from Thailand and Vietnam. And if we zoom into Japan, we can see that we have brought on a third supplier based in Kanagawa, Japan. With this third supplier based in Japan, we would expect our risk to be much lower. Analyzing this scenario, we can see that the cost has increased a tiny bit more when compared to scenario 3. Sourcing costs have gone up since we are now sourcing from Japan. Looking at the risk ratings, as expected, the risk has dropped to 4.9. However, we would expect that to be much lower. And looking into the finer details, the network risk has dropped significantly. However, the supplier risk has essentially stayed the same. And the reason behind the supplier risk staying the same is because Japan has high biolab proximity, and it is an island at risk for tsunamis. One other thing that we wanted to investigate while building into this model was greenhouse gas emissions. And going back to our data and looking at the user-defined variables table, we have set up 3 data variables to track production emissions, transportation emissions, and sourcing emissions. If we go ahead and filter by finished goods, production emissions, this will be associated with the production plant in Japan for all products. And this is a production variable. The coefficient will represent the number of tons of CO2 that are produced from making a unit of product. And by filtering by the sourcing emissions, this will be a flow constraint. And what this is saying is from each of the suppliers from the baseline into the plants into Japan, this shows the amount of carbon associated with flowing a unit of this product. And finally, we have our finished goods transport emissions showing the carbon emissions of flowing units of goods from the distribution centers to the customers. After running the scenario and looking at the optimization user-defined cost summary, we can see the total amount of carbon associated with each scenario and each variable. To set a constraint and cap out carbon emissions, we first need to go and set this in the user-defined constraints table. As you can see here, we are taking the variable of finished goods transportation emissions, setting a max constraint, and asking the engine to find the best network while having a max carbon emission output of 40 million tons of carbon. If we go into the scenario tab and view the fifth scenario, we are including the constraints of maxed out emissions. Going over to the Analytics tab again, we can visually see the transportation emissions capped out at 40 million.
What is really interesting with this scenario is that we are able to achieve this reduction in greenhouse emissions with a very marginal impact to cost when compared to scenario 4.
In conclusion, the China exit strategy in Asia model is a valuable tool for companies seeking to reduce their reliance on China for production, while still maintaining production within Asia. The model provides several scenarios to answer the key question of whether and how to start exiting from China. The scenarios range from the baseline unoptimized supply chain to scenarios that eliminate Chinese raw materials entirely and include candidate suppliers in Thailand, Vietnam, and Japan. The scenarios help in understanding the cost implications and risk associated with each scenario. From the analysis, it is clear that exiting China entirely increases the risk to the company and results in a cost increase. However, reducing reliance on China by sourcing from other suppliers while also maintaining some sourcing from Japan reduces the risk and provides a more cost-efficient solution. Companies that use this model will be able to make informed decisions regarding their supply chain and exit strategy, which will help them reduce risk and maintain profitability in the long run.